So just your weekly warning that this lecture is being recorded and uploaded to the Echo and uploaded to YouTube. So today what we're going to do is functions. So what did we end up with last week and the week before? So let's recount what we've learned. So far we've been utilizing Python in a computer basically to do arithmetic, right? Leaning into this notion that a computer is a fancy calculator. We talked about the memory model that the computer has, and that is to say that we can consider memory to be a really long sequence of bits that is sort of off-on toggles that the computer can go in and move from the on to the off position, and doing so with certainty or deliberately, we can modify parts of memory to store things. And we learned that Python has an imperative called the assignment operator, where we have something like x is equal to 7, which we're now going to read as x gets 7, or understand that to be an imperative to place something into memory. Then we talked about the various things that we could put in memory that couldn't be changed. That is the immutable data types or the primitive data types that included the integers, floats, booleans, strings, and tuples. There's one thing that I wanted to show you with tuples that I neglected to show you last week, which is kind of important. So I'll show you that now. I think that's the right Python environment. Okay, so I'm just going to go into Python. Remember, if you see 3 chevrons here, the interpretation is that we're typing into the REPL, the read eval print loop. So there's something called, we finished by talking about tuples, right? So if I said x gets assigned the tuple 1, 2, the type of x is a tuple. But there's something called tuple packing and unpacking, which is kind of useful. So if you put a bunch of values into a tuple like this, you can pull them out by doing this. All right, so doing so, oh, sorry about that. So doing something like this will allow you to pull A, B, and C out. And also, if you've assigned things to A, B, and C, I can place them all on one line like this and print them. So I often use tuple packing and unpacking to save vertical space, right? Because I can assign 3 things at once and I can print 3 things at once. But this is quite useful when you're doing your work as well, right? Because otherwise I would have had to say something like this: A is equal to 1, B is equal to 2, C is equal to 3, and that takes sort of 3 lines, right? So my preference is to use the tuple packing and unpacking. So don't be surprised by that if you see it emerge in the lecture. Okay, so functions are very, very important. Okay, so we talked about the 3 component pieces of the programming language that we're working on, with being sequence, selection, and iteration. That is to say, the programming language has to be able to read a sequence of commands from top to bottom, right? Bare minimum. Now, what commands can we give the computer? And remember, the computer can only do arithmetic. I give the computer a picture of a bird, and the computer identifies that the picture of a bird is a picture of a bird. What sequence of arithmetic accomplishes that task? We don't know. Fundamentally, that's what's happening, but there's a lot of sort of steps in between there, right? So we don't really write one program that knows if a picture of a bird is a picture of a bird. We write a sequence of programs that do a bunch of little things, and then we tie together those programs into one big program, right? So if you want to, the first thing I described is called Big Bang programming, trying to accomplish one giant thing in one giant program, and that rarely works. What we want to do is take a problem and decompose it into smaller problems so that we can tackle the individual problems and then tie together the solutions to the individual problems so that in concert, that they work to solve the big problem. And the little constituent pieces are called functions, right? So what I'm going to teach you today is how to bundle a few lines of Python code into something called a function, so we can utilize this basically as part of our problem-solving strategy, right? So user-defined functions are perhaps the single most important feature of a programming language. Functions enable us to abstract away complexity by bundling lines of code together. And furthermore, these functions are going to form the building blocks of everything that we do. So your first assessment, for example, is actually just a series of individual functions that you're going to have to program individually and then tie together in the end. The other benefit of working with functions is that if we break the task into smaller tasks and write functions for accomplishing them, we can test those functions. We're never really certain that the software is working as intended, but the more smaller pieces that we break it into and certify that the smaller pieces are working, the more confidence that we get when we connect them together at the bigger, that the bigger program is working, right? So we've already used functions. We've been using the functions the whole time. Like multiplication was a function that took two integers and returned an integer. Max was a function that took an arbitrary number of numbers and returned the biggest one. So the relevant things here is that each function, so there's like a vernacular or language that we have to be familiar with here. Each function takes input, right? Some information or data that's being handed to it that it's allowed to utilize in its function body. It then takes, it does a sequence of instructions and then hands something back to the user. We're going to study this quite carefully. Okay, so you've seen functions already. So we're going to sort of think about what functions meant in mathematics. So I'm sure all of you seen something like the parabola like this. F of x is equal to x squared plus x plus 1. This is a parabola. You know in math that if I sort of said f of 2, that was an instruction to go into this expression over here and to find every instance of x and replace it with 2. This actually is called binding x to 2. In Python, we can simulate this type of functionality like the following. So I'm just going to go over to here, the Python REPL, and start typing out some things. Okay, so I'm going to define a function in the Python REPL, but this is we never sort of define functions in the Python REPL because it becomes unmanageable, and I'll show you why. Okay, so let's just define that parabola. So I can say def, which is a Python keyword, right? So I said there's a series of words that we're not going to be able to use as names because they have special meaning for Python. So def is such a keyword. So I'm going to say def, and when Python reads that, it says, oh, the user wants to define some type of function. I'm going to give the function a name f, and I'm going to delineate now what inputs that it's receiving. So in this case, it's going to receive one input x, and then I'm going to put a colon here. Now, usually when I hit enter at the REPL, what happens is that Python evaluates that line. Here, if I hit return, you see 3 dots instead of a chevron. So Python's actually context aware that we're trying to define a function, and these functions typically take multiple lines in order to define. So Python's just saying, oh, okay, user's not finished typing yet. I shouldn't evaluate anything. I'm just waiting for input. So here, I'm just going to say 1, 2, 3, 4, return x squared plus x plus 1. And I hit enter, and I hit enter again, and you see those 3 chevrons. And now we have access to this function in this REPL instance. So if I type f, what will you expect to happen? So what does it mean, right, when Python read that function? That means, and I'll go to here, I have this visualizer. Okay, so this is the Python visualizer that we used last week that sort of gives you an illustration into the memory of the computer. And I want to show you what happens when Python reads a function. So what happens here at line 1, Python says, oh, there's a function. This function is going to be a list of instructions that the user is going to want to repeatedly utilize. So I'm going to load that list of instructions into memory, right? It goes into memory the same way like a number would go into memory or a list would go into memory. So that's why we get this fancy arrow now. An instruction set is a little bit more complicated than something like 2, but there we go. So at line 1, Python loads that instruction set into memory, and it makes it available through f. Now, here, if I type f, it's going to say, yes, f is an object. It's a function that's living in memory, and that's where it is, right? So we never really utilize that by itself, the function itself. The function only becomes useful when we give it input. So if I give it input like this and hit enter, what has happened is that this x, well, we'll just go back to the visualizer. So if I execute that line f of 3, what happens is that Python finds that instruction set in memory. It says, okay, I should now set that x to 3 at that header, and then continue with the function as if x is equal to 3. So if x is equal to 3, at line 2, we're going to get x 3 squared, which is 9, plus 3, which is 12, plus 1, which is 13. So that's how you read this. This is a call to the function f, where its X input is being set to 3. And I hit next here, and you see that we get a return value of 13. And we can repeatedly call that function as many times as we want, right? So here you see I've loaded a function in. I can see that it's in memory. And then I can also, this is called invoking the function. Now, here's the problem. Suppose I realized that that X was supposed to be 2 times X. How can I now go change that function? Well, you can't. If you hit up, actually, what's going to happen is it's going to just scroll through everything that you've typed previously, right? So in order to fix that function, I would have to go in and type everything again. Now, do you think that this is going to be manageable for us to have to retype the entire function every time we want to make any change to it? Of course not, right? You're going to be writing functions. There's going to be dozens of them. You're going to be writing hundreds of lines of code. So what we do instead is we write function definitions into a file. So on the right-hand side here, I have a file. It's called sandbox.py. py is the file extension typically used for Python code. And I'm just going to go ahead and define the function in here instead. All right, I'm going to say define f of x and return x squared plus 2 times x plus 1. Okay, and then what I'm going to do here, okay, I'm going to go out. So I'm using something a little bit different than your Python idle. You somewhere on idle should see like a play button. So I don't have this play button, but what I do instead, which is totally equivalent, is I just type this command in. Oops, sorry. Ignore me for a moment. Okay, so I'm going to type this, but it is absolutely equivalent to you pressing the play button on idle. Okay, so don't be too concerned about not understanding that instruction. If you want to understand it, it's just the command to the computer to say execute Python 3 in its interpreted mode and hand it all of the instructions that are in this sandbox file. Again, just hit play and you get the same thing. So I do that and I'm in the Python REPL. It seems like nothing has happened, but now I do have access to a function f and I can go ahead and I can utilize it, right? And now if I see that there's a mistake in this function, I can just go ahead and change it, right? Maybe it's 20. And then just you hit play again or reload or whatever. I think it's F5 or so. It depends on the IDE that you're using. So this is how I'm going to be programming for you now from now on, right? Everything that we're going to do is going to be in a function. That's the minimum units of software that we're going to write. It's like the software atom. And I'm typically just going to define things in a file and then run them in REPL, right? So we can play with them. All right, let's keep going. So in Python, 4 spaces or indents are significant. I said, so a function basically bundles a sequence of instructions that belongs to it. So this begs the question, how do I indicate what lines belong to the function and what other lines don't belong to the function? And the answer to this, and this will be the answer for every control structure, is to use 4 tabs, right? So when you define a function, everything that's 4 spaces in minimum is going to be considered to be in the body of that function. If you get errors along the lines of indentation error, unexpected indent, you should go check your formatting. This is why we're working in these fancy text editors. Oh, I think, hold on. This is why I have a white space rendered, so you can count 1, 2, 3, 4 lines there. So this is the purpose. This is why you can't sort of write code in Word, right? You need some type of special text editor, which is going to highlight things for you and show you when things are off. Okay, so that's the purpose of working with this Python idle. Okay, so we've done Python tutor 1. I showed you. So this is a somehow more sophisticated function with 2 variables now. Yes. Would an indentation error be a syntax error? That's a good question. Ask that on the EdStem. I probably think it would because it violates the syntax of the language. But I don't want to say yes or no yet because I'm not actually quite sure. I know it's an indentation error. If an indentation error is also a syntax error, because it didn't usually it says syntax error when there's a syntax error. So maybe I can say that this is a syntax error, but it's one that can be more specified than sort of just saying I generally don't know what's going on. In this case, I know you're just missing some spaces. Okay, cool beans. So I guess if the question is what should I answer on a test if that was the case, I would put indentation error in, and that would be the correct one to select. Okay, so these functions don't just need to take one variable, they can take two variables. Like multiplication was something that needs to take two numbers to return the product of a number. So functions can actually take as many variables as you would like, as many inputs as you'd like, including 0 inputs. Here's one that just takes two numbers and multiplies them. But I want to study what happens here, bringing to bear everything that we've learned. So I've defined, if I define a function in the REPL, so I sort of say f of x and y is a function which returns x times y. You see nothing gets printed. But remember, last week we talked a lot, just because something doesn't get printed doesn't mean something hasn't happened, right? So remember, that is when something doesn't print, that typically indicates that something's been moved into memory, right? So that is a function that is now living in memory. You can always ask, right? If you're unsure, like f is in memory, but g is not. And that's always, you can determine what functions exist. Okay, so at line 4, the function f should already be living in memory. So here's a typical question that we sort of ask on tests. At line 4, what will happen? If I execute line 4, what will you see and what are the changes in memory? Those are usually the two things that we're concerned about. What is being displayed to the user and how has memory changed somehow, right? Because that's effectively what computation is, changing your memory around. So any guesses? So let's go through all of the things. At line 4, is there any syntax problem? Is this a valid expression that can be executed? Okay. What imperative is being performed at line 4? Pardon me? Assignment, right? We're storing something. What is being stored at line 4? Yeah, whatever the function hands back when we call it. Okay, so that's why this return keyword is very important, right? The function is going to execute a bunch of commands and it's going to hand something back to the user, and the thing that it hands back is delineated by that return keyword. Okay, so in this case, Python says, oh, into a variable called x, I need to store the return from this function f. And what does f return? So I'm going to find it. There it is. I need to set x equals to 3 and y equals to 2. If I set x equals to 3 and y is equal to 2, then I'm going to return 6. At that point, you can just regard this as being 6, and then 6 gets stored in x. Does anything get displayed? No, because this is an assignment operation. The imperative is a change in memory, not a display to the screen. And what is in x? 6. Okay, so memory has been changed somehow. What about something like this? How can we parse something like this? Is this syntactically correct? Yes. Okay, so it's a little bit more complicated. So let's use the Python tutor to run through it, if I can actually ever get this to work. That one, this one. Okay, so that's the same example from the slide, and I want to show you how Python is going to walk through sort of how calling this function. So at line 1, Python sees the def keyword and it says, I need to load a function into memory. So that instruction set is now in memory. It's called f. It's ready to be called. Here, I'm going to hit next, and you're going to see what's the next thing. Well, what's the next operation that you think Python is going to do? It sees that it needs to call that f, but it needs to hand over some input values. But it looks at inside, and it sees that those input values are also calls to f. So those calls to f have to be resolved first. So this is how that goes. So it looks at line 4, and it says, oh, I need to call f with 5 and 2. That's the first one it found in that. It goes up to here. It gives 5 to x, 2 to y, and it returns 10. Well, it will return 10, right? So we have a return value of 10 when f is handed 5 and 2. The next thing it will try is that one, right? So it says, okay, I now also need to obtain the value for f when it's handed 2 and 3, right? So it finds the instruction set again in memory. It says, here is 2 and 3. This is what I want you to utilize for your x and your y. It gets to that return statement down there with 2 and 3 and returns 6. Okay, so now Python knows that that is 10 and that is 6. So minus 10 plus 12 is 2. That is 6. So we have a function called to f with 2 and 6. We go down to its instruction set. It says, okay, I need to return 2 times 6 to the user, and I get a return value of 12. Okay, so this actually stores 12 into x. And that's how it sort of walked through that, right? So you have to go inside out. Yes, sir. If I change the function before. Okay, so use line numbers. That's why they're there. So
then change what f did to x, y.
Okay, here, so you're asking what happens if I redefine f?
Yeah.
At what line? Here?
Yeah.
No, because it's already stored that in x, right? So yeah, if after line 7 you changed f, subsequent calls to f would be different. But those other calls have already been made. Okay, good point. Okay, so return, we've seen this. It's a reserved word. That is it to say that it's another word in Python system that we're not allowed to use as a name. We can't assign anything to return. We can't assign anything to def. It is used to designate what value the function should hand back to the user. Right? It's always an input-output type of exchange. User gives the function something, function gives the user something back. The thing that's being handed back is designated by this return statement. It's a statement. It isn't a function, right? It's a keyword. So you don't call it with rounded braces, but we'll discuss that in a bit. Print, on the other hand, is a function that returns nothing, whose side effect is printing something to the screen. So I want to have a long discussion now about how print and return are not the same, right? There's I've been teaching computer science for 10 years, and this problem has persisted for that entire decade, that people think print and return are the same thing. Worse, people use print instead of return. I'm going to show you why it's so enticing to do so, but you need to understand return is a keyword and print is a function, right? That's a big difference. Now, so let's discover what happens here. If I print something, and I said print is a function, so it must be returning something. If I assign the thing that print returns to x, what is the behavior? So I want to know what prints to the screen and what's stored in x. So what prints to the screen? That one should be more obvious. Hello world prints to the screen. That's the imperative of a print. But what is stored in x? Nothing. Okay, so there's a new literal. There's a one extra piece of data that I didn't talk to you about, and it's none. The type of none is none type. Okay, so it's a special constant in Python that's utilized for like the absence of data or like an error signal or something like that. But specifically, so print is a function that has a side effect of printing hello world, and it ultimately returns none. Okay, so this distinction is important because return and print can look like they're doing the same thing. So I'm going to define a function f of xy. Let's do it here instead. Be more interactive. I'm going to define f of xy. Okay, 1, 2, 3, 4. And I'm going to print x times y instead of returning. Up to this point, we've been returning. Okay, so f23 gives 6. F5, 0 gives 0. So that seems like it's working, right? Okay, but if this is working, I should be able to do this, right? We did that before. Not working. And furthermore, there's other things being printed to the screen. Isn't that kind of puzzling? All right, so to see what's happening here, I'm going to say let x equal f23. Let y equal f, I don't know, 5, 0. And we're trying to do z is equal to f of xy, and that's failing. What is in x? Nothing. What is in y? Nothing. Okay? Because the print is a function, and every function has to return something. So when you have a function that ought not to return something like a print is an action, right? In other programming languages, we have a difference between a function, which returns something, and a procedure, which just does something. But in Python, there is no such distinction. We can only define functions in Python. So if you have a function that only performs an action, then we return none. And that's what print is doing, right? So that's why that won't work. but it looks like it's working, right? So be careful, be very careful. Okay, if a function does not have a return statement, it is presumed to have return none as its last line. Every function in Python has a default return, and that default return is none. So really, that f that I defined looks like that. There is a final line in it that says return none, and that sort of makes it obvious why things weren't working. Now, we're not supposed to put that in. Sort of bad styling, but I think at your level, if you want to put it in, I've told the tutors not to mark anyone down for that reason, even though technically speaking, it's not part of the Python enhancement protocol, but it's not a bad idea to put it there, right? While we're learning. So just keep that in mind. Absence of a return type, a function is going to return none. So compare this with the use of return. So that's that same function now. Now I'm using return instead of print. Right? Now I can say f gets what's handed back by f. Y gets what's handed back by f. We're no longer getting weird prints, right? That was the other thing that was sort of bizarre for this function. When I said x gets f of 2, 3, isn't that weird that we had a print statement there? We normally don't see anything when issuing a storage imperative, right? So that was another sort of signal that things are sort of kind of weird, right? So print, be careful with print. There's like virtually no cases where you should be printing. So here, if we say x plus y, then we're fine, right? Because we've properly stored a number in x, we've properly stored a number in y, and those two things can be added. So notice return is not a function, it's a reserved word, okay? So you do this, return space expression. Don't do this, return brackets expression. The problem is not the second example here. Python is going to accept that's syntactically correct. That's fine. Python's not going to complain. But let me put it this way: if return, you're calling if you were to do that, you're calling return like a function. And if return's a function, then what's return using to return? Like turtles all the way down, right? So return isn't a function. So don't call it with braces like this. It's return space and then an expression. This is bad styling. I see that a lot. Okay, so now I want to study what outputs. The important thing about return is that it ends the party. Once the function returns something, it says, I'm done work for the day. I'll see you next time that you invoke me, right? So this is odd because now this is going to be the first instance in this class where I'm going to write Python commands that don't necessarily get actioned by Python, right? So when we do the if statement lecture, which is the second part of this will be more obvious that we can skip things, but this is important. Just because you write an instruction down in your list of instructions does not necessarily mean it gets actioned. Does not mean Python's actually able to reach it, is the terminology we're using. So I'm going to show you about this reachability now. So here's a function called example. It's going to print twice and return. So I want to study what this does by saying what prints and then what gets stored in memory. Okay, so if I say A gets assigned what example hands back when given a value 1, is this syntactically correct? Yes, it's an imperative to store something in memory. What's it storing? So what prints and what stores in memory for a duck?
It could print 1, then 2, then 4, 3.
Perfect. So there's your duck. You come claim it afterwards. Okay, so my colleague down there said it will print 1, then print 2, then return 3. And this is not mysterious. Like this is in this course, all you have to do is just go line by line. Just act like Python. Nothing is ever going to be confusing, really, if we can just act like Python. So Python says, at line 1, Python says, I need to load an instruction set into memory and call it example. So there's now an instruction set called example in memory. At line 6, it goes, user wants me to store in A the outcome of passing example instruction set the input 1. It goes then back to line 1. It says, okay, that X, you're 1 now. Goes to line 2, prints 1 times 1, 1. Goes to line 3, prints 2 times 1, 2. Then goes to line 4 and returns 3. Okay, so exactly 1 is printed, 2 is printed, 3 gets stored in A, and we can see that. That makes sense? I'm going to move stuff around now. I've permuted the return statement and the print statement. Now who wants to give a go at this one? Yes, miss. Yes, exactly. So here's a duck for you that you can come claim. My colleague down there said it's going to print 1, and then it's going to return 3, and then done. Okay, so in particular, that line is unreachable, right? Once you hit a return statement, Python exits that routine. All right, so two lessons here. Return ends the party. And just because you write a Python command doesn't necessarily mean that command gets actioned on. Not all statements that you write are necessarily reachable. Okay, so this one, we're going to see 1 prints, and we're going to see a storage of 1 into A, or 3 times 1 into A. Okay, 2 returns. Who wants to give this one a go? Go ahead. Okay, so yes, I suppose I had to give you that. So you said, could you repeat what's it going to do again? Anything print? No prints, okay? And it returns what? 3. Okay, perfect. So there's a duck for you all. Our ducks are in order. So if you go here, so line 1, Python loads an instruction set into memory. At line 6, Python says into a value called A, I need to load in the output of example when given 1. It finds the instruction set for example, sets X to 1, return 3, ends the party. Okay, so it's the first return that is triggered, is the one that sends the value back. And this is not uncommon to see multiple return statements in a function. Okay, yes. No. This is valid Python code. This is Python code that's in the system that I'm running, and you're seeing exactly what outputs as if I were to put this in Python code. You can write it. You can write an arbitrary amount of expressions underneath that. Nothing's preventing you from doing so because it is a valid program. You just put a lot of garbage in it that can't get reached. Python can't enforce good coding. It can only enforce a language sort of feature. So yeah, all right. So be careful about that. So A has 3 in it. Okay, what outputs here? All right, so I'm going to say A is equal to example when handed 1. So what's stored in A and what prints? Yes, sir. Nothing is stored in A, and it prints 2. It's because, do you see a return statement there? Is there a return statement there? I said, absent a return statement, Python just assumes return none is the last line of the function. You can actually just assume return none is always the last line of any function that you write because one would think you wrote a return that gets triggered earlier. Okay, but there is no return statement there. So it returns none. So that print happened because that's an imperative to print something to the screen. So when 4 triggered, example was called, X was made 1, we printed 2, and then we sort of hit this hidden line where it says return none. So A is none. It doesn't show anything. It's the absence of data, right? So if that's sort of, you have to understand none doesn't have a string representation necessarily. It's just showing nothing, right? So I put a little gap there to emphasize that. But the type of A is none type. Okay, and we're going to be utilizing this because sometimes we want to, like a function may fail. And in that case, we may say we're either going to return a number or none in the case that we fail that computation. Okay, so now I want to induce a condition under which we should utilize functions because everyone says, well, when should I bundle lines of code into a function? And the answer for this is, this is kind of something that you just sort of get a feel for eventually. But this is a good example of when you sort of should utilize it. Has anyone heard of this formula? This is a nice little formula. Did you know that you could compute the area of a triangle knowing its sides? Right? This is pretty cool. So what you do is you find the perimeter of the triangle. You call that S. You half it. So S is half the perimeter. And the square root of S times S minus A, S minus B, S minus C, that's going to give you the area of the triangle. Okay. Before we continue, I want to code this up. But before we continue programming anything, what we have to do is have some type of example in mind so we know if the thing that we're programming is working or not. Okay, so what I'm saying is, can anyone nominate a triangle, which we're going to use as a usage example for which we know the area is easy to obtain? Equilateral triangles, sure. Those are all triangles, but like a specific triangle with honest to God sides. I actually think the right angled triangle would probably be the best one to. Does anyone know any right angled triangles? 3-4-5 triangle, my favorite right angle triangle. What's the area of the 3-4-5 triangle? 6. Okay, so there's our usage example. A triangle with sides 3-4-5 should have area 6 if we've programmed everything properly. Before you ever hit enter on your computer, when writing Python code, you never do that without first having some expectation of what you're getting back. Otherwise, why are you hitting enter? You're just going to see a number. You're going to be like, okay, that's a number, right? So usage first. This is like test-driven development. Usage first, then program, right? So you know when you've programmed something wrong. Okay, so here's the first way that we could program this, and it looks like that, right? We just type in all of the numbers. We like implement that Heron's form. Is it Heron's formula? Yeah, Heron's formula exactly as written. Is there any pitfalls from doing it this way? Well, first of all, will it work? Cool. So this is how we should do it. So what's wrong with, like, let's critique this. Like, what are some ways that if you saw this in code, would it scream at you, this is an area of a triangle calculation? I don't think so. What happens if is it easy to make a mistake if you're typing this all? What happens if you have to do this 100 times? You want to be typing this in 100 times? No. Okay, so this is kind of messy. There's a lot of repeated, so something. You want to utilize names and functions to limit code duplication. That is one principle that I can sort of give you. Is there any duplication in this? Tons of duplication. Okay, so step one, like look, 3-4-5, 3-4-5, 3-4-5, 3-4. We've done it a whole bunch of times. So step one, let's utilize names, right, to simplify this a little bit. So here I'll say I have A, B, and C. 3-4-5. Here's my side S, right? And now I can just use S and A and B and C. This is a little bit better, right? If I wanted a new triangle, all I have to do is change the values at line 1. And someone who's sort of familiar with Heron's formula may already be able to identify this as a triangle calculation. Okay, so it's now more compact, 3 lines. Okay, suppose I still want to compute the area of a triangle like 100 times in my code. And I've duplicated this 100 times in my code. Is that good? What happens if I made a mistake? What happens if I did the triangle calculation this way 100 times in my code, and then old mate comes around and says, hey, you forgot to divide by 2 at line 2. How many places do I have to change that code now? Every single place that I wrote it. Okay, so that's bad, right? That's why you wouldn't leave it like this. We want to bring it all the way. And I want to be able to define a function like this. So here's a function, def, right? That's the keyword that we need to utilize in order to define a function. Heron, that's a pretty good name for this function. It takes 3 inputs, A, B, and C. And then it calculates S, and then it returns back the area. So then I can say something like Heron 3-4-5. So this is the best option out of those 3 options, right? Because 1, it's pretty obvious now what Heron, like you're calling something. Perhaps people even know what Heron is, so it's more evident that you're doing an area calculation. If there is a mistake in my Heron calculation, how many places do I have to change? How do I have to fix something? 1 place, okay? How many places do I have to test if Heron function is working? 1 place, right? So this is sort of part of the software pipeline. It's like, okay, we know that we need to compute area of triangles. So we should write a function for that. We should test it, convince ourselves that it's working, and then hand it over for the software engineers to utilize. So now they're going to utilize this. Other benefits of defining things in functions. Suppose you found out a faster way than this of computing the area of the triangle. You could just go into the body of the function, make it faster, and as long as you don't break the area formula, everything that's dependent on your function now is also faster. Right? You could have these things propagate. These functions are modular, right? It's like if I had a car, if I took out the engine and put in a faster engine, that car drives faster. Like putting a new engine doesn't suddenly break the steering, right? So this is how we're going to be designing software, so that we have a bunch of functions that we can sort of plug and unplug and improve and plug back in so that the whole thing sort of improves. Okay. Was there a question? Yes. Yes, that is a mistake on the slide. That should be 6.0. That's very astute. Good observation. I think that deserves a duck. Why did my colleague down there say that this should be 6.0? Yes. Yes, there's a float up there. And as soon as you introduce floats into the system, it sort of pollutes the system. So yeah, these slides aren't actually executing Python code. So sometimes we may find this little mistakes like this. Okay, so we want to improve that function a little bit by adding extra commentary about the function that's for humans, right? So this is sufficient for Python. Python doesn't care to go anywhere more than this, but we as humans can't leave it like this because we need to program with one another. So in mathematics, you would sort of delineate the domain and range of all of your functions, right? So if we had this Heron's formula called triangle area, in math, we would say, oh, this is a function that takes 3 reals to the reals, right? Its domains is all triplets and its range is all reals. In Python, we can write the same thing. And I'm going to insist that we do this. So we can add a bit more decoration. So I'm just going to go over here and sort of define that Heron's formula. So def Heron, okay, A, B, C. Okay, and what did I say this was? It was S is equal to half of the perimeter, A plus B plus C. And then we want to return the square root. So I guess that's everything to the power of a half of S times S minus A times S minus B times S minus C. I'm just going to go ahead and call that in, and we'll use it. Okay, so let's see. Do I have Heron? Yes, it's in memory. Can I call 3, 4, 5 and get 6? Yes, I get 6. Okay, so here are some of the extra decorations that we're going to put on. So I want to say this should be a float. This should be a float. This should be a float. And we should return a float. Okay, so this is called a type hint or a doc annotation. It's not, so we're using Google's style of programming in Python. Let's aim high. And in Google's Python enhancement protocol, they insist on these type of doc annotations. I really like them because now you can look at line 1 and you get a bunch of it. You at least at line 1 know what the function is expecting as input and what the function is going to hand back to you as output. Okay, so that's the first step. Now, something that's very confusing about this, perhaps, that's a comment. Python is ignoring all of that. Python doesn't have a type system. So if I were to do this, okay, let's change this to string, and reload. What do you think will happen if I call Heron 345? 6.0. Is 3 a string? No. So is Python enforcing anything that we wrote up here? No. Okay, so that is very, very important. We are including these type annotations, but Python does not enforce them. This is a human thing. These are comments. This is for readability of the code, not enforced. This is maybe confusing if you're from a different programming language, because in C, you're obligated to do this. And in C, it does get enforced, right? But C is a typed language. Python is not a typed language. Yes, sir. I believe so. Let's see. No. There is a way to put anything there, because we will eventually declare custom types. So we're going to have to add types to the system, but this is actually a newer feature of Python, are these type annotations. So they've been great. There's also, if you care to know, if you use this bar operator, that stands in for or. So I can write something like this, and now this returns string or none, right? Or you can have this returns a string or an integer, and the same's at play for the inputs. But don't worry about that too much. For now, I just want to make you aware that in our functions, we're going to be type annotating the input and output because that's helpful, but it's not going to be something that's enforced by Python. And I put this on every midterm and every exam that I've ever written at this university, and people still get it wrong. Right? So please don't get it wrong. Right? It does not get enforced. Okay. So there are other things that we want to do with this function. So every function should have a doc string. And a doc string is effectively a description of so we want to be able to code for one another. So this means that if I coded this Heron's formula, I have to write in a description that's sufficient for other programmers to be able to use it without looking at the code. Now, this is not a place to describe how the function is working. No one cares how your function is working. If we want to know how the function works, we look at the code. Your audience are people who know how to program in Python. What you need to do here is give some description of why is this implemented? What will it hand back to me, and what is it expecting? So something like computes the area of a triangle with sides, or I think technically speaking, return the area of a triangle with sides A, B, and C. Right? So I usually use angled brackets to indicate that I'm talking about one of the input parameters here. This is not universal. Sometimes you see people use underscores like this. Some people don't use them, right? So you just got to find whatever flavor that you dig. I dig this one. It was sort of the one that we're using when I was working at the University of Toronto. Okay, so step one, you need a description of what the function does. And then what you're allowed to do is designate a bunch of preconditions. So what preconditions do you think we require here? Like, was our function always working? Is it the case that I can compute the area of any triangle as long as its side length is a float? Are negatives floats? Like, were we expecting something for this? Is anything preventing us from calling this function with negative numbers? No. Okay, so that's something we have to now consider. So how do you think that we should prevent negative numbers from coming to this function? Yes, sir. No, I don't think so. I want to be lazy. Pardon me?
Wow.
I want to be lazy. I don't want to enforce them. That's the answer. Like, I know this is, I'm going to sound facetious, but this is what you do. You can state preconditions. I'm going to say A, B, C are greater than 0. Now everyone asks, okay, what happens if the preconditions are violated? Well, then the function's not going to work. So this is a philosophy in Python that's called blame the user. I know it sounds kind of funny, but that is what we're doing. This is why we're adding so much decorations to these functions. Like, we've already so think about it this way. What inputs are allowed to come to Heron? Is anything preventing non-floating inputs coming to Heron? Nothing's I can hand this thing strings if I want. Nothing's going to prevent that. Yeah. I would like for our questions to be for the purpose of becoming better at programming in Python. Learn how to program in Python. Yeah. Probably, yeah. Right. If we say write a function, this is why I don't want to answer these questions, because now it's going to be on a recording. And then if I deduct a mark, someone's going to pull up the recording of this and complain to admin, right? That's why it happened. So for the purpose of your exam, write Python code with as much clarity as you can bring forth, right? And if we say write a doc string, we do expect for you to delineate the appropriate preconditions in that doc string, right? Because for every function that you're going to write, you're going to write a doc string. Every single function is going to require you write a description, delineate preconditions, and indeed provide a usage example. Like this. Okay? And the reason is because Python cannot enforce any of these rules. So we need a secondary mechanism to say, look, this is the intended usage of this function. This function requires that you pass me floats. It also requires that those floats are positive. If you don't pass me positive floats, you have broken the contract. This is another term for this is a type contract, and you should not have any expectation that the function will work. Right? That's how we operate in Python. It's called blame the user. So if you write preconditions in your function, you just assume that those preconditions are met, because if they're not met, then the user called them wrong. So if you do something like this, and I'll show you what happens. So this is like effectively what we want comprehensively to be included in a function, a description, preconditions, a usage example, and headings. The reason we do that is because now, if you call that code into Python and you ask for help on it, whoops, you're going to see that. Right? So this should be sufficient information in order to utilize that function. In fact, you could ask for help on like effectively anything in the system, and you're going to get stuff like this, right? So whenever you define a doc string like that, it's going to be available to you when calling help. So the idea here is you need to give enough information to the user who's calling help on your function for them to be able to utilize it. And that information is, what should I hand it? What's the quality of the things that are handed to it, and what are you going to hand it back? And it's great to actually see like a usage example like this. And furthermore, eventually I'm going to show you, there's actually a tool that can go and validate all of these usage examples. Actually, I should do that. So providing these usage examples is also, you can automate testing by putting in this usage example, but we'll get there when we hit testing. Okay. So there we go. So type hints are not enforced. This is very important, but we're going to include them for documentation. So this is the Heron's formula and its full form, right? Having a description, preconditions, area. And here's the quality or the framework for an arbitrary Python function. So if you want to have a Python function, you have to say def. Then you have to give it a function name. The name has to satisfy the same naming rules that variables have. So it can't start with a number. The only symbol that it's allowed to utilize is the underscore, but otherwise do whatever you'd like. Then you can have 0 or more arguments, right? So you don't necessarily have to take in an argument. We do have functions that just perform actions that don't necessarily need input. So you say, here's my first argument and its type, second argument and its type, and then you designate a return type. Okay. So then follow that up by a short description, then a precondition, then some usage examples. And indeed, you are obligated to do this on your homework. So on your assessment, and you're going to be furious with us. You're going to have definitions that are like returning constants. You're going to have to write like 10 times the amounts of documentation than code. But this is just what it's like working in software. Okay? Yeah. Oh, this this doc string? Yes, it has to go there. So you don't have to include it, but Python is looking for it to be there, right? So normally, if I'm like defining a function in class, you may just see me do this, right, before I continue, right? Just to remind myself that eventually I should be writing a doc string in there afterwards, but it's not necessary for it to be included. But this is one of the way that this class is going to be different than other classes just learning how to program. Those classes aren't going to be obligated to write any type of documentation. But believe me, if you don't document your code, you'll look at it a month later. You won't know how anything works. Right? It's happened to me. It'll happen to you. I think it's one of those lessons that you just have to learn painfully. Okay, so PEP, this is the Python enhancement proposal. Just got changed today, actually. It's a set of agreements among programmers. So I just told you that we have these doc hints and usage examples and this blame the user approach. All of those decisions have been codified into this document, which changes. So technically speaking, we're going to be programming according to that enhancement proposal. Specifically, we're using Google's variation on this, right? So these are buttons. So if you go download the slides and click, you can find it. You can also just search Google's PEP 8. The head TA for this course actually has, I think, provided a style guideline, because I think what's going to be most relevant here is how you have to utilize this to get the full marks on your assessment. So look out for that. But otherwise, don't be overly, don't be hindered by trying to follow all of these rules. Like I'm going to violate, it's somehow something that you strive towards. Right? None of us are sort of programming perfectly. Like the objective is always clarity of code. Code in such a way that your code is clear and concise. So give that a look, but here's some highlights. Generally speaking, our variable names need to be, this is called snake casing. This is called camel casing. So variable names and functions should all be snake case. They should all use lowercase letters and snake casing to delineate word boundaries. So we have descriptive variable name, but we do not use camel casing. Camel casing is reserved for classes. right? So there's a lot of sort of hidden rules in Python where it's like, oh, if something's capitalized, that should be a class. Does anything enforce that? No, it's just sort of an agreement that we've all made. So there's a lot of these sort of like handshake agreements that we've made that you're going to have to be familiar with so you can work with other Python programmers in Python. You can't code beyond the 80th character. This is also going to irritate you, but this is still at play in all industry. If you see my editor here, you see how there's a white line there? That actually designates the 80th character, right? So I think you can add this line in idle, but when you upload your work to Gradescope, it will tell you, hey, the following lines have bled over the 80th character. Please go correct them. You do get graded down. Yeah. Yeah. Are we prejudiced to space in this class? No, we're not prejudiced to space. So yeah, because it's invisible? Well, that's the point I'm trying to make. If you said, oh, could I put an X there? Well, I guess space has a special meaning by Python. But yeah, spaces will count. Spaces will put you over the edge. Okay. So what I then do have to tell you is that because obviously some of your lines are going to be longer than 80 characters. So the easiest way to deal with this, because technically speaking, you can't define an expression over multiple lines. If you put redundant brackets around something, then Python will allow you to define it over multiple lines, right? So that's the easiest way to break up a long expression over multiple lines. Simply use brackets. But when you do, this is how you should be aligning everything. They want sort of like the operational character to be on the left and the first one to be leading like that, okay? Pardon me? I believe you, sure. Yeah. Well, you could go to 80. If you could break this up in whatever way you like. But this is sort of, I don't know, this way, again, I can't say under any case, what should I do? The philosophy is always what will be the most descriptive? What is going to be the most clear to write as a programmer? Because you even see in this, there are some subgroupings that have been kept on the same line for that reason. Okay. Comments. Anything followed by a hash is going to be ignored by Python. It just considers that human stuff. Okay, so anything green, effectively, depending how you're coloring, or for me, green is going to be ignored, right? So all of that stuff up here is ignored. Anything here is ignored. And the reason that we want to have these comments is because we want, it's not always going to be evident from the code what is happening. Right. So we insist that you write in comments into your code when appropriate. Now, I always get asked the question. I think actually this question was asked day 0. Do I have to comment every line of code? No, that would be nuts. Where should you comment? You comment in order to induce clarity. Right. So the general philosophy, I can tell, if you're trying to write comments in order to get marks, you probably will lose them. That's the wrong mindset to be in. If you're writing comments in order to induce clarity on your code, then you'll get them. So here's an example, okay? Because I think often novice programmers end up explaining what Python is doing rather than why you are doing it. Remember, the people reading your code know Python. You don't need to explain to them how Python works. So if I were to encounter a line in your code at your review that said x is equal to x plus 1, and the comment there says increment x, I'd be like, but I can see that you're incrementing x. Every programmer can see that you're increasing the value of x. The relevant thing is, why are you increasing the value of x? Right? So the second comment is helpful. Oh, we're compensating for a border. Oh, I better not remove that. Okay, that's why that's there. Right? So you basically want to add a comment if there's some line in your code which just seems out of place, or what is that? Or you've done something sort of clever. Right? So do not describe what the code is doing. Describe why you are doing it, why something is in the place. That's the general philosophy at play here. From day one, we've always wanted to use spacing for good, not for evil. Right? So we want to generally do stuff on the left, you're grouping according to priority of evaluation. You're putting sort of spacing around equals. But again, don't let this encumber your programming. First program, you can always go through your program code afterwards and clean it up. There's tools called linters. Have you ever heard this term, linter? These linters are effectively tools that help you style your code according to the sort of rules, right? So every company is going to have some type of style guideline that you're going to be obligated to follow. So as a grunt worker, you're not allowed really to complain, oh, I want to use camel casing. Well, you just got to follow the styling. I've had to follow styling that I don't agree with, but so is the case. So let's just write quickly a function that takes 3 integers and returns the number which is not the smallest, right? This is a class exercise we did a couple weeks ago, just so we can go through all of the component pieces of making it. Okay, so I can do something like define middle number, something like this. The middle number is going to take 3 numbers, an integer, int, int. This returns int. Oops. I'm going to have to do a doc string. This returns maybe the sum of them minus the smallest one of them minus the biggest one of them. Okay, so then I need a description. So something like return the number among x, y, and z that is not the largest nor the smallest. Are there any preconditions that we need here? Well, that effectively is the precondition insisting on that. So yes, I agree with you that we have to insist that they're integers, but I think that precondition is accounted for. Any other preconditions that you think we need? Yeah. I think they can be, oh. No, I think they're okay if they're all the same. Yeah, because yeah, the max of 3 equal numbers is the number, the min of 3. So this will still work if all numbers are the same. I think we don't need any preconditions for this one, right? So I just want to demonstrate that it's not always the case that you're going to have preconditions. So you can just skip that in this case. But we do want some usage example like middle number, 3 minus 5, 9. And what's the middle number there? 3, something like that, right? And we can call that in, see if it works. Whoops. Middle number 3 minus 5, 9. 3, cool, that one works. Okay. I got moving to the second one. This was an exam question from a few years ago. What does this return? So what don't you see? Do you see a return keyword in this? So absent of the return keyword, what does the function return? None. So this one returns none, right? So that was a little bit of a tricky, but when you see a function and you don't see a return statement, that should sort of be hitting you in the face. Oh, this is weird. This is a procedure. This is returning none. Is this valid Python code? I defined a function which takes the product of 2 things. I said they need to be integers and I pass it a string. This is going to error. This is going to work. So this is perfectly fine Python code. Remember, just ignore that, right? If you're trying to think like Python, ignore all the type annotations and then ask yourself, is this valid? And yeah, it's valid. You can multiply strings by integers. In fact, this one didn't even have any interaction. So I'm just sort of handing back the first one here. So be careful. Like this is a source of much confusion amongst novices, and I totally understand why. It's kind of weird, but again, it's a human thing. Consider this as a comment. It's effectively a precondition that we're insisting on in order to use the function, because there is no typing in this system. So we'd have to spend all day checking that X is not any of the things that could possibly be not the thing that we want. So if you want a type system, you can use C or Java or something like that. Okay, so blocks of code can be grouped to form functions. Functions take 0 or more inputs and hand back a single value by a return type. This is going to be anytime we do a class example now, it's going to be in the form of a function. This is the smallest piece of code that we're going to work with. Okay, so selection is next. Let's go to selection. We got another less than an hour. Okay. So I said that the imperative programming paradigm is characterized by 3 things: sequencing, selection, and iteration. Sequencing was you have a sequence of instructions that we're reading top to bottom, and if you change the order of that instructions, probably the program behavior is going to change. Selection is the provision to skip some of those instructions, right? So you can imagine having, we call it control flow, right? So you have a flow of your program top to bottom, like instruction 1, instruction 2, instruction 3. And now we can do something like if something is true at the moment, skip some of the following instructions. Okay, so that's what selection is going to be. Selection. Okay, so we need to skip lines. And in order to skip lines, we're going to have to ask a question. Basically, should I skip this line? And we those questions are always going to result in a yes, no answer. No, you shouldn't skip it. Yes, you should. Except we don't use yes, no in computer science. We use true and false, or 0 and 1. Okay, so I want to remind everyone of the basic operands of logic. Okay, so because what I want to be able to do is have, so now I can say this, a function who returns a Boolean is called the predicate. Right, so anything that returns a true false answer is going to be called the predicate, and those are going to be the things controlling our capacity to skip some code. And if you have one predicate, we want to be able to take those predicates and make more sophisticated ones by joining them together using and or, conjunction or disjunction. Some of you are in 1061, should be learning this sort of more directly at the moment. Okay. So the Booleans are just these two values, true and false. We've dealt with them already when we talked about primitive data. You know that we have true, we have false, and in fact, any data in the system has a truthy or falsy value. So any function that maps into the Booleans is called the predicate. The Boolean function greater than is a predicate, right? It takes two integers and returns a true false answer, right? So I can show you that the type of true is and the type of false are Booleans. And now I can sort of say, what does 7 greater than 3 evaluate to? True. Okay. Is 7 greater than or equal to 7 plus 1? What did I teach you last week about the order of evaluation of comparison operators? When did they happen? Last, after all arithmetic. So that arithmetic happens first. So 7 greater than or equal to 8? False. Okay. What about this one? I now changed the order of operations by putting some brackets around. I'm just trying to see if I remember what we did last week. So this will become, is 7 greater than or equal to 7? Yeah, that's true. Can we add true plus 1? Does true have an interpretation as a number? What is true's interpretation as a number? 1. 1 plus 1 is? Perfect. Good class. Right? Because the integer value of true is 1 and the integer value of false is 0. And we talked about truthy falsy and the general guiding principle, things that are 0 or act like 0 or false, everything else is true, right? That's why -2 is going to be true there, right? And it just, so this means I just have to tell you what the 0 is of every type. And, or conjunction, right? So this is called the predicate. So it's a predicate that takes two predicates and gives you a new predicate, right? So, and this is called the truth table for and. This is like a multiplication table. Right. So whereas in a multiplication table, you may have like 2 times 3 is 6. In this table, it's true and false makes false. So that's how you can read this. You only really need to remember one thing. And is true only when both of its inputs are true and false everywhere else. So that's the one you only have to remember. And is true only when both inputs are true. Okay, so here's an example. I want a red fast car. So that's a car that is both red and fast. Okay, so if you bring me a red slow car, rejected. If you bring me a blue fast car, rejected. If you bring me a blue slow car, double reject. But if you bring me a car that is fast and that is red, you accept that. Right? So this is just a building block to take a predicate and to build more sophisticated ones, because they may be more sophisticated once you start programming. Or disjunction. This one is the trickier one because its usage in the English language is different than how the mathematicians use it. In math, we have a stupid joke. You go to a restaurant, the waiter comes to you, he says, super salad, and you go, yes, right? Because the mathematical or, both can be true. What we utilize in English is called exclusive or to the mathematicians, where only one of them can be true. Okay, so here's the truth table for or, and you only have to remember one thing. There's only one way to get false out of or, and that's for both inputs to be false. So the only way to get true out of and is for both inputs to be true. The only way to get false out of or is for both inputs to be false, right? So for the car example, I want a red car. I want a car that's red or fast. So a blue fast car does it, a red slow car does it, a red fast car doubly does it, but a blue slow car doesn't because it doesn't satisfy either of those conditions. So is 3 greater than 7 or 7 greater than 3? That is true because 7 is greater than 3. Is 3 greater than 7 and 7 greater than 3? False, right? Because 3 is not greater than 7. One of the inputs is false. Is 0 less than 3 and 3 less than 8? That is true, right? This is checking if 0 is in between 0 and 8. And in fact, in Python, we have a nice syntax which allows you to express line 5 like line 7, more mathematically, right? So this is saying, oh, is 3 in between 0 and 8 strictly? And the answer is true. And you get all variations, like with the equals and the greater than, right? So you can test for ranges quite nicely. Okay, so consider that true or false and false is ambiguous. Okay, if I bracket it from the left, you're going to get false. If I bracket it from the right, you're going to get true. So what do we need? So is this expression ambiguous as written? Yeah. Are we allowed ambiguous statements in a programming language? No. How did we fix that with expressions of numbers? We had to delineate some order of operations, right? Or some associativity rules. Okay. So I'm going to tell you this is true. Can you deduce anything from that? Yes, miss. The and happens before the or. You got a duck for that one. I'm going to put it here. Right? Because if we did or first, what would happen? What's true or false? False. And false is false. So that can't be that. Okay. So otherwise we did true or false, and that will be true. So the rule is actually and has precedence over or. So you do the ands first, then the ors later. Second question, if I see multiple ands, which one should I do first? It's technically left associative, so bracket from the left, but it also doesn't matter. Why doesn't it matter? And is commutative. Can you say this without using the mathematical vernacular? A and B is the same thing as B and A. It doesn't matter if you swap them. This plus is commutative. 2 plus 3 is the same thing as 3 plus 2. So that means if you see any expression with lots of ands in it, you're free to permute everything. So it doesn't really matter how you bracket it in that case, right? So the only thing that you have to remember, and before or. But I don't think this is really relevant because you shouldn't generate, because you're going to be writing these expressions. So you really shouldn't write something that requires like a lot of thinking. You should use brackets, right, to try to make it more expressive. If this was a logic course where I'm going to give you an exam trying to trick you, then fine, that would be relevant. But that's not what we're going to be doing here. So you can go home and try to bracket the following expression so that it evaluates to false. There's a bunch of them. For bonus points, write a program to find all the bracketings of this that could get you to false. That would be pretty interesting. Okay, so there's one more logical operation that's not. This is the highest order of precedence, right? So if you see nots, ands, and ors in the same place, do not first. Not is basically the negation operator for Booleans, right? So not true is false, not false is true. Okay, so let's just go through some examples. Here's the tuple packing that I said that I'll be utilizing. This is a try to not use not. You can generate really confusing statements when you start doing double negations. So is the term De Morgan's law familiar to anyone here? Yeah, so there are some rules for distributing knots across these expressions that you can look up. They're called De Morgan's laws. Again, I don't think they're going to be quite relevant because we're not going to be giving you very complicated things. But let's just have an adventure to see what happens when you start putting knots in front of things and ask, is this inducing clarity or not? So how about this? Is A equal to 6 and B not equal to 5? So is A equal to 6? True. Is B not equal to 5? That's also true. So this is true. Is it not the case that A is equal to 6 and B not equals to 5? Right, because like this effectively is the true statement from the one above. Is it not the case that A is equal to 6 and B not equal to 5? That one is false. Yes. What about this one? Is it not the case that A is not equal to 6 or not B not equal to 5? I don't know. True, I guess. But like, don't write something like line 12, right? Like doing things with a lot of double negations is going to produce really confusing predicate statements. So be careful with some of these new tools that we're giving. Add a single not to this statement in order to get it to evaluate to false. That's a fun exercise. Okay, so now I get to talk to you about the lazy nature of this programming language. We've had lots of questions about this. So there's two types of programming languages, eager evaluative programming languages and lazy evaluative programming languages. In lazy programming languages, the programming language won't do any work unless it's absolutely required to. I think all of us as undergraduates understand this type of philosophy of my whole master's degree actually was on lazy computation. But let me show you how it's at play in Python. Okay, so when is or something that involves an or true? Yeah, when at least one of its inputs is true, right? Okay, so let's study this statement. True or do we care? No. As soon as the first thing is true in an or, we can conclude that it's true. Okay, so but the thing is here is like 1 divided by 0, is that allowed? So the question is, does Python ever, but I can type that. That's syntactically correct, is it not? So the relevant question then becomes, does Python action that command? Because we've learned just because we write something doesn't necessarily mean that something gets actioned. So no, because of the lazy nature of this programming language, that is permitted. This is called a short circuit. In eager languages, that would throw a division by 0 error. It would do all of the work. Okay, so keeping that in mind, let's see if we can resolve the rest of these. False or 1 over 0? Really? False or, don't we need to know what, doesn't the second thing have an opportunity to be true? So false or, this means, no, I then have to, I need to know the truthiness of that. I have to. Now it's a 0 division error, right? Because in the second example, it had to try that. Make sense? True or access a variable that doesn't exist. That one's true because this is syntactically correct and Python doesn't try to execute that. So it has no opportunity to discover there's nothing in memory with that address. Okay. True or syntax error. Can Python read this? Can't. Can names start with bashes? No. So this doesn't even get read by Python because it's not part of its language, because you can't start a name with an exclamation mark, right? So that one's a syntax error. Okay, so this doesn't prevent you from getting syntax errors. Okay, so but keep this in mind when programming, because people can get confused by the lazy nature of it, and it can be confusing. But you can also exploit it. That's the other thing. Okay, true and 1 divided by 0? Error, right? Because okay, in order for and to be true, both things need to be true. So it's insufficient to conclude if the first thing is true. False and 1 over 0? False, right? Because if anything's false and you can conclude, right? So that's how the short circuiting manifests in conjunctions. A is equal to 3. A equal to 3? True. A not equal to 3? False. Is this syntactically correct? And if it is, tell me what it does. Who said that? You get a duck. Okay. Learning objective. So somehow novice programmers get trapped into the belief that the only place you can find predicates are in control structures. Not the case. Predicate statements are expressions like any other expression in Python. And because they're like any other expression in Python, you can store their outcome in values, right? So this, I'm saying, store the outcome of that comparison in B. And A is not, so false. So B stores false, right? So you can put the outcome of comparisons into variables and then utilize them later, right? These are not trapped in if statements, which you better get to. Determine the output, true plus 2. I think that's 3. 7 times false, 0. Okay, this is just another assignment, so that gets to false. That one we can skip. Okay, so the truthy values. So values in Python that evaluate to true are any things that are not empty, right? So not the empty string, not the empty tuple, not 0. Okay, and here and the falsy values are the ones that are 0, empty string or empty tuple. Which one of these expressions are going to evaluate to true? Let's just go through them in turn. Number 1, is it not the case, empty, and hello? True or false? Okay, let's go through this so there's an and there's 2 parts of this. So not empty tuple, what will that evaluate to? I thought empty tuple is the 0. Okay, so let's scrutinize this a bit. So what is bool of the empty tuple? False. So what is not that? True. Okay, so that's true. And what's the truthiness of hello? True. So that one is true. What about this one? True or 1/0? True. Bool of space. Good job, because we don't have prejudice towards the space. Bool 2 greater than true. 2 is greater than true. True, because true is 1. Bool of false. Ah, good on you. Okay? Because that's just a string, right? What if I said bool false without those quotations? Then it's false. Okay, so there are some times where I'm going to try to trick everyone, but don't, like the reason I'm trying to trick you is because that's what's necessary for determining bugs in code. It's not easy. You have to have a very detailed eye for this. You have to know what pitfalls programmers are going to fall into in order to correct them. And so I'm not trying to be cruel. I'm trying to help you understand that you have to know all the ways things can go wrong. Okay, so here's the truth about and or. It's not quite a predicate. It's not actually returning true or false. It's doing something more flexible than that. And I actually want to utilize that flexibility when writing code. So if you can put anything in Python has an interpretation as true or false. So therefore, anything in Python is a valid input for and or. Okay, so if you give or some values, it's going to return the first one that's true or the last thing. If you give and a bunch of values, it's going to return the first one that's false or the last thing in all cases. So can we all remember that? It's the first thing that's true for or the first thing that's false, otherwise the last thing. So what should 0 or 2 return here? Well, 2 is true, right? So this would return true generally, but I'm saying it's not actually returning true. So I'm saying it returns the first thing that's true. What's the first thing that's true in here? 2. 2. 0 or 2 is true, but 2 is true, right? So it doesn't bother like reinterpreting all of these objects as different things. 0 and 2 returns the first thing that's false or the last thing. 0 in this case. Okay, more. Empty tuple, singleton tuple, couple, and or. What does it return? The first thing that's true or the last thing? What's the first thing that's true? Is empty tuple true? Is singleton tuple? Yes, so that thing. What about this? First thing that's true or the last thing? First thing. 1 and 2. First thing that's false or the last thing? Yeah, first thing that's false or then the last thing. So nothing in there is false. So it's just the last one. First thing that's false or the last thing? What's the first? Is there anything false in there? Yeah, empty tuple. Okay. First thing that's false or the last thing? Well, in this case, it's the last thing is the first thing that's false. This is useful because if you have a bunch of things and some of those things are empty and you want the first non-empty thing, this will do it for you. Right? So there are some actually clever use cases for using and or in this thing. It helps you select the non-zero element if you ever need to choose without having to use an if statement. The if statement. Okay, so this is our first control structure that I'm going to introduce. And every time I give you a control structure, I'm going to show you a flowchart. Okay, so this is how, so I have to kind of help you how to read a flowchart. So the if statement, so given some condition C, and some predicate that evaluates the true or false, right? So a condition is something that is a predicate, returns a yes, no answer. An if statement is a control structure that executes a blocks of code only when C is true, right? So another way of saying this allows us to skip lines of code. Technically speaking, this allows us to induce the movement through code, but it's equivalent. So this is what an if statement looks like in its most basic form. Right? It's something that allows you to skip over code. So these arrows indicate control flow, right? So above this arrow, your program's running. And then eventually you hit a diamond. And a diamond is a way to indicate a decision, right? Some condition is being checked. So you hit this diamond and it's saying, okay, check if C is true. If C is true, then run this code and continue with the program. Otherwise, if C is false, then skip this code entirely. Right, so this is the first thing that we have that can actually control the movement through our code. Up till this point on, we're only able to go top to bottom and like go out to functions occasionally. That's the only thing that's been happening. The general framework for an if statement is this. You say if, that's a keyword, so we can't have a name called if. You give it some condition, a predicate that sort of evaluates the true or false. This colon, that's very important. And then everything that's four spaces belongs to that control structure, right? So anything four spaces in a function denoted belonging. So four spaces here for if statements denote belonging, right? So we say we're controlling something. The thing that gets controlled is everything at least four indent levels in. All right. So here I'm just going to show you the most trivial if statement. Okay. I'm going to set as x is equal to 0. And if false is true, which it's not, execute this line of code. So does the line of code 3 execute? Yeah, x is going to be 0 because did Python arrive at this line? No, it got skipped because of the if statement. So again, the learning object, just because you write a command, doesn't necessarily mean it will get actioned, because now we can control how we're walking through the instructions themselves and we can skip some of them. So this is the most basic way that I can prove that to you, right? I wrote something down that didn't get executed. What happens if I change that to true now, right? So if it's true, increment x, does now x change here? So now it becomes 1, right? So I showed you how the if statement can skip something, and I showed you how the if statement can trigger, right? You may see this in other Python programmers. Since every value in Python is technically true or false, you sometimes just see people put a name in an if statement, right? So here I say x is equal to 0, and you may see if x. And this is a way of saying if x is not 0, or if x is 0, do the following, right? So that one, if 0, which is false, means skip this. So x remains 0. X is equal to 1. So this is sort of what I want to pay attention to. This is a non-zero check. Whereas in other, to do a non-zero check, you may in other programming languages see if x is not equal to 0. But in Python, you never see that, right? Because every value already has true or false connotation. To do a 0 check, you usually say if not x, right? That determines if something is non-zero, right? So this will become more once we start playing with these things, that's when all of the comprehension is going to be start landing. Okay, so here's a function foo, which takes in one input x. What's the first thing that strikes you about this function? No return. So what is it returning? None in all cases. Okay, so what's the behavior of this? If I I want to give this very large number to foo, what is going to get stored in answer? Be careful. What's going to get stored in answer? Yes, sir. None. None will get stored in answer. Okay, but it's going to print large positive and positive, right? Because if we walk in here, it says, okay, user has called function foo. It's handed me 10 to the power of 6 for x. 10 to the power of 6 is greater than 0, so print positive. And 10 to the greater than 6 is bigger than 10 to the power of 5, so print large positive. Obviously, that's sort of not what we want this function to do. So how can we go ahead and try to correct this? Suppose I do actually want to hand back a string and not just print it. What should I swap out here? Yeah, I should swap out the prints for returns. That's the first one. But if I say answer gets 10 to the power of 6, what is it going to return back? Now we're going to get positive. That's still not quite what we want to do. We exited too early. So how can I fix this? Yes, sir. I think that's the best answer. So sequencing. I said the order of the instructions matter. And if we change them, we're going to get different program outcome. If you switch these if statements, then the program starts working as intended. Right? It's the same set of instructions permuted. We'll have one's incorrect, one's correct, right? So that's why the sequencing comes to play here, right? So just keep that in mind. Sometimes merely switching the order of these if statements will give you the outcome that you want. Take care when defining variables in if statements. Okay, what happens here? So I have an if statement. It doesn't trigger. I'm saying answer is equal to 0. What happens if I try now to retrieve what's in answer? Yes, sir. Namer, you didn't define, nothing's there, right? Because it didn't actually trigger that line, right? So again, just because you write a Python expression doesn't mean it's going to get actioned on, right? So you need to be really careful if you're ever defining variables inside an if statement. You should probably define a default value for that, or use a different style of if expression. So I'm going to go a little bit more quickly now because I have to do the rest of this in 20 minutes. But back when I used to bank in the 80s, you had to go to the bank with a book. You handed them this book, and then they printed your balance in the book. And if you had money, it was printed in black. And if you were overdrafted, they would print it in red. Okay, so here's a piece of code basically that's telling you if your bank balance is in the red or if it's in the black. Now, what I want to notice here is, so does this work, right? You check the balance. If it's positive, then you're in the black and you're not in the red. And if it's negative, then you are in the black and you are in the red. Is there anything wrong with this code logically? No, it's fine. Now I want to imagine that checking the bank balance is hard. You need to call the bank, wait on hold for 2 hours. Is there now a problem with this code? I'd say so. You're doing something expensive twice for no reason. Okay, so the other things that we want to utilize in if statements is, if a previous if statement fails, you have information now at the next line. The only way to arrive at line 5, not in this example, but I can contrive examples where the only way to arrive at a given line is for certain things to be true. Like for, I think I have a different example there. Okay, so here, for what we need here is basically not a way to skip code, but a way to branch on code. Right, so now we have a different type of control flow where you get to pick your journey. Right, so you're sort of running your code, you hit this condition. If it's true, go left. If it's false, go right. Okay, and now I can write an if expression like this. This is called an if then else. Right, so if the condition is true, it's going to run this code, else it's going to run that code, which means I can rewrite that previous expression to be something more like this. If the balance is greater than 0, then in the black is true and the red is false. Else, do the opposite. Right? Because now here, you know, the only way to be here is for this to have failed. And if that failed, then you can utilize information at line 5 about that failure. Right? So that's right. So this is what the if else expression is for. You don't actually need to be limited to 2 branches. You can have as many branches as you would like. Obviously not 0, right? One or more. So an if statement with 1 branch means skipping. If statement with multiple branches means choose your own adventure, right? So you can have as many conditions as you want. The flowchart for that looks like this. I did it for 3 conditions. If I did more, it would just look very messy. So effectively, you check your condition. If the condition 0 is true, then you run block 0 and continue through the code, and you don't touch any of the other blocks. However, if this fails, then you check the second condition, and you check the second condition under the knowledge that the first condition has failed. Right? So here, you know that not C not. So if this is the case is true, then you run that block of code and continue. If this is false, then you go to the next condition. At this condition, you know that C not has failed and C1 has failed. So you should utilize that information somehow. If that's true, you run that block and you continue. Otherwise, you've skipped all of the branches, right? We can add an else branch in here if you want. If statements can either obligate you run code, that's the else branch, or you can just simply skip. That's without the else branch. So the provisioning of an else branch means that the if statement is certainly going to run at least one thing. Okay, age is equal to 60. Here's some code. I want to give people beer depending on what their age is, right? So I'm pretty sure the drinking age in Queensland is 18. So what does beverage get assigned to in this setting? What are we giving someone who's age 60? We'll just run through the code at line 3. Is 60 greater than or equal to 18? Yeah, so we're going to set beverage equal to cheap beer. Are any of those other branches going to run? No. Okay, so what is the value of beverage at line 10? Cheap beer. Is that what we intended? No. So can I get some recommendations to how to fix this?
But first time we can put if age is greater than equal to
Okay, so your suggestion is use ranges. Yeah, like use a range. No? Oh, okay. Yeah. Right. I see. So basically, reverse the order of which we're checking these conditions. That's a great recommendation. Yes. Get rid of the equals. What do you mean? But then won't that break it for when we do want to assign people 18? Yeah, that would fix it for this exact example, but not, I think, working whole. So I like the notion. Well, so one fix is to use ranges like this, and we've provisioned them. So that's gonna to make everything work. But I think a cleaner solution is to simply reverse the way that we're checking these conditions, right? Because if this fails, then at line 5, you know the age can't exceed 50. That's just deduced by that point, right? So this will work. Is this code working as intended? Is there any other edge cases that we have yet to consider? Yes, miss? Yeah, what happens if a child comes in? What should we serve the child? So this is an example where certainly at least one branch has to have run, right? Because everyone coming in has to be designated a type of drink. And we've totally missed anyone who's under 18. So what I actually want to do is just add that else condition, right? So certainly one thing is going to run. So now we have something happens, and if all conditions fail, there's like a sort of catch-all condition. And that catch-all condition in this case, I'm just going to say everyone else gets apple juice. Right? If you make it through this chain, everyone else gets apple juice. That's what that else condition says. So here we go. We got apple juice. Okay. Factoring and refactoring. So you learned how to factor in school. And in that context, it meant to take a number and to decompose it into its prime factors. Like 12 was 2 squared times 3. Factoring is actually a more broader term for taking something and dividing it into pieces. So refactoring means to take something, divide it into pieces, fix those pieces, and then put it back. So what this means with respect to code is that so I've just shown you a bunch of instances where we can write code in a variety of ways to accomplish the same outcome, but some of those ways were like definitively worse than other ways, right? Required more code, had more opportunity to introduce bugs and stuff like that. So I want to show you, and so these are examples these are novice pitfalls. And so every year anyways, this is some instances where you'll probably write the stuff that I'm showing you, and I want you to be aware that you shouldn't write it like that and how to change it, because it seems really nice. So this code refactoring is something important. Once you finish your assessment, it's working. That's only step 1. Once it's working, that's great. That's a lot of great work that you did, but now you have to go in and clean it up, right? Because there may be lines of code that are unreachable, or you may not be PEP compliant. You may have lines over 80. So once it's working, you want to rewrite it in such a way where you can simplify your code base. So for example, every time you have an indent level, I want you to feel physical pain, right? It's not necessary, like embedding control structures in other control structures is generally something that we want to avoid. This is a reflection of the complexity of your program, and we don't want our programs to be complex. We want our programs to be able to be understood and maintained by others. So what's wrong with this? Is anything wrong with this? Will Python accept this? Okay, so there's nothing sort of programmatically wrong with this. Under what condition will print hello trigger? If all 3 conditions are correct. So isn't that this? Don't do the former, do the latter. Right? So if you ever embed an if statement in an if statement, you need to ask yourself, am I just hiding away the and? Probably. Okay, so that's the first lesson. Don't be embedding if statements in if statements if you can avoid it, if you can replace it with an and. Right? So that's one refactor that you can do. How can this be simplified? If x is greater than 0, return true, else return false. Just return x greater than 0. This again comes from this novice mistake of thinking that the only place you can put predicates are in if statements. They are not. They are expressions in their own right? So you don't laugh. You may find this in your code, right? It's obvious because I wrote it like this.
you may implement a more non-obvious version of this, but effectively doing the same thing. If you ever have an if statement that returns true or false, how is it doing that? Well, it has a control, and that's the thing that you should just return, right? So that's very common. This one too, if x is greater than 0, y is true, else y is false. You can just sort of assign the outcome of that predicate statement. This one I see all the time. Is anything wrong with this? If x greater than y is equivalent to true, do the following. Will Python accept this? Yeah, nothing's wrong with this. Why is it bad? Aren't we always checking for true? Isn't that what we're implicitly expecting? Like, we're asking if that is true. You don't have to say, is it true that that is true? Right? That you're sort of double doing that checking, right? So don't, like, people put it there because it reads better, right? Python is a very idiomatic language. It lets you use a lot of English. And I'll show you some other places where that pitfalls too. So don't ever say something is equal to true. That is what it is. You're asking if it's true, if this is equal to true. That's redundant. Same thing goes for false. This is a little bit more forgivable, but how do you suppose you fix doing comparisons to false? Yeah, you effectively just put a not there, right? If you want to check if something's false, you're actually asking if it's true that not the thing is true. Okay. You can talk about, so these are a bunch of questions that you can work at home, basically discovering that sequence if statements aren't the same thing as if else branches. So do go at home and try some of these questions. The answers are there for you. This can be refactored to exactly one line of code. I promise you. So you can, we'd never give you something like this on a test or anything, but it's quite fun, right? Because again, like if this fails, then you have information that you can utilize at the following lines. Okay. This one I want you to pay attention to because I'm going to put this on your midterm and exam, 100% probability. And people still get it wrong, despite me saying, don't get this wrong every year. What does this statement do? What does this statement say? If x is equal to 1 or 2 or 3, print hello. Under what condition is that going to print hello? So what does that mean, sir? Always. How do we read this? If x is equal to 1 or 2. What's 2? True. What is anything or true? True. So isn't this just true? That's if true. It seems so nice. Oh, if x is equal to 1 or 2 or 3. That sounds like it should be checking one of those things. But no, that's how you check if x is equal to 1 or 2 or 3. When we do lists, we'll be able to do it like this. But be careful. I'm going to give you some variation of this question on your midterm and exam because it happens all the time. And it's a very hard bug to find because you'll just have an if statement triggering. You'll have an if statement that effectively is not an if statement. It's just handing over the control. Okay. Here's some common errors. I see this as well. People think, I don't know, they forget that the if statement exists. You don't have to have branches on if statements. You're allowed to skip code without having a branch. So I'll see something like this, like if x pass. Pass is like the empty Python statement. We need it because spacing indicates belonging, but that's just totally equivalent to this, right? So you should never have an empty if branch, right? You are allowed to skip code. Okay, so blocks of codes can be skipped using if statements. This control flow depends on the evaluation of predicate statements. Next week, I'm going to introduce to you the very last component required to get all of imperative programming, and that is going to be the control structure that allows us to repeat pieces of code. And once I give you those three, I can technically send you off to develop all software. So you'll be fully empowered next week. Of course, we're going to be doing more, but do your EdSTEM lessons, 50% if you haven't even opened it yet. Next week, I'm going to give a more full-throated yell at the class, but please try to get those numbers up. Okay, see you next week, everyone. Oh, come collect your docs, honor system. Yeah, thank you.